Hello everyone. We are from Operating System Group 9, and today we'll be presenting our project, which is the title is Process Synchronization in Windows. And my name is Yong Wei Jing, and my metric number is 261482.
My name is Dowen, metric number 261761.
My name is Edwin Ong. My machine number is 264072.
My name is Tian Kenjing, 263461.
Okay. The first thing we're going to talk about today is the structure involved in this process synchronization. So it's basically a simultaneous execution of multiple threads of process to reach a handshake that they can commit certain sequence of actions. So logs, mutex, and semaphores are combined, and they're the example of a process synchronization. Mutex log, it stands for mutual exclusion or mutually exclusive, where the code has to be created and opened in order for the process to be read. So the theory revolving this mutex log is it is basically a lockbox that requires a key to unlock and view its process. So next thing is semaphore, which is a significant technique which is used to manage concurrent process by using a simple integer value. So it's simply a variable which is a non-negative and shared between the threads. So it's basically used to solve critical section problems and achieve process synchronization in a multiprocessing environment. So following is the binary semaphore, which is also known as the mutex log, which only contains two values, which is the zeros and the ones, and is basically initialized at a value of 1. Next is a critical section, where it's a segment of code which is access shared variables and has to be executed as an atomic action. It means that in a group of cooperating processes, at a given point of time, only one process may be executed and must be executed in the critical section. So the following is the general structure of the process. So this is basically how it looks like. So we are using an example of a few threads, which is maybe 3 or 4 threads. So in this figure, it shows 3 threads where n is the name of the thread, while the true and the false, or 1 or 0, is the semaphore's value. So it basically gets the mutex log and unlocks it with a key to enter the critical section and access the protected shared variable data. Upon completion, it will release the log and enter the remainder section while changing the semaphore value to 0. And the next is the other threads, which is thread 2 and thread 3, will repeat the above steps until all the threads are done. And then the system will generate a calculation of the total at the end of the whole process. So next will be the step by step of the operation involved, which will be presented by Wei Jing. I'll hand it over to him.
Now I'll be explaining in detail in step by step in the operation involved. So in this assignment, it will be conducted by a program using the command prompt and implementing Java programming language to calculate the GPA of the student by allowing them to input the grades of 3 subjects that represent the traits. And the step I'll be explaining below is the first step is the user will be provide the GPA of their 3 subjects, which are represented as a trait as input, and the program will then queue the traits according to their sequence for them to get the mutex log in order to access the protected shared variable, which is the GPA. And the third step is upon getting the mutex logs, the trait unlocks the unlock and access into the protected shared variable and enter the critical section where it's temporarily save all the input data from it traits into it. Once the thread is done, the threads will exit the mutex log and release it back while it enters the remainder section and complete any undone process. And the fifth step is the thread is finally completes the whole process when it is released itself from the mutex log and make it available for other threads to acquire the mutex log. The sixth step is the thread 2 and thread 3 will repeat the step until the thread are complete. And lastly, the system will then calculate the data in the protected shareable variable and print it bring it out into the command line. And now I'll be explaining the weakness of this implementation. So actually we found that there are several weaknesses in this implementation. The first is this is a standalone program, which is this program only runnable on the local window that the code is compiled. Standalone also refer to a software program that do not require any software other than the operating system to run. And the second weakness is not an executable program. So this program will lose all the data after the program is closed. This issue has become one of our main drawback in this implementation because it must actually recompile every time to rerun the program. So the third weakness is this program run using Java. So why we said this is our weakness, because Java was historically considered slower than the fastest third generation type of language, such as C and C++. So this because Java programming run on a Java virtual machine rather than directly on the computer processor as native code such as C and C++ program. So now I'll be passed to my teammate Tiong to explain more on advantages.
Next, I will present about what are the advantage reason why the specific OS choose the solution implementation or algorithm. The advantage of Windows implementing the process synchronization is to avoid rest condition, deadlock, and other related conditions. It is necessary to synchronize access by multiple threads to share resource. Synchronization is also necessary to ensure that the interdependent code is executed in the proper sequence. In Windows, to synchronize access to a source, the user can use one of the synchronization object in one of the wait function. The mechanism is a thread that issue a wait request to the window by using the handler of the synchronization object. When an object enters the signal state, the Windows release all threads objects that are waiting on the synchronization object. The function described in this section provides mechanism that threads can use to synchronize access to a resource. A synchronization object is an object whose handler can be specified in one of the wait function to coordinate the execution of multiple threads. More than one process can have a handle to the same synchronization object, making inter-process synchronization possible. In Windows Win32 programming, the following object types are provided executively for synchronization. In the table, event, which means notify one or more waiting threads that an event has occurred. Mutex means can be owned by only one thread at a time, enabling threads to coordinate mutually exclusive access to a shared source. Semaphore means maintains a count between 0 and some maximum value, limiting the number of threads that are simultaneously accessing a shared resource. Last is waitable timer, means notify one or more waiting threads that are specified time arrive. Next, I will pass to Wen.
So I'll be explaining the commands, tools, and utilities that are related to the area of management involved and the function and sample executions of the command. So the first one that we have is IntelliJ, which is the editor that we use to write the soft code and also for debugging and compilation of the program. And next we use Maven, which is a project management tool where the source code can be easily exported or cloned for other users to use. And go down. Okay, so I will share the IntelliJ. I'll share the demo. So Edwin, can you stop?
Yep.
Yeah, okay. Okay, is the screen on? Okay, so this is the source code for the program. So first we have 4 files here. First we have the main. This is where everything gets instantiated. So we have the runnable, which is what the thread does, which is the function of the thread we have run here. And we also have the get mutex function for the specific threads. And we have the mutex object itself. We have the title. We have the Boolean to see whether or not it's acquired. We have the method, which is to acquire the mutex, or we can release the mutex. And lastly, we have GPA, which is a class just to keep the scores. We can add it and then we can get the total CGPA. So in the main, what we do is we prompt the user to enter 3 scores first. And then once we have the 3 scores, we instantiate 3 threads, and then we start it. And once it's started, then it runs through the run method and tries to complete its transactions. So let's try to demo the program. So first we get score 1. So we can enter any number between 0 to 100. So yeah, you can see here that thread 1, it gets the mutex lock first. So once it gets the mutex lock, it locks any other threads out. So thread 2 and 3 was actually blocked. And then thread 1 proceeds to process the calculation. And then once it finishes processing the calculation, it releases the mutex lock. And once it releases, the thread 2 is able to get the mutex lock. And then once thread 2 gets the mutex lock, it blocks the other threads. So it's left with thread 3. So thread 3 is blocked. And then thread 2 proceeds with the calculation. And then when it's done, it releases the lock. And then thread 3, finally, it gets the mutex lock. And then it processes the calculation. And then it releases the lock when it's done. So after all 3 threads have run, then we get the final output, which is the GPA that it has calculated from the 3 threads. So we get 3.41 GPA. And we can try again to see if there's anything different. So as you can see, this is actually the same. So thread 1 gets it, it blocks the 2 and 3. Once it's done, it releases. But then this time, thread 3 actually gets the lock first. And then it blocks thread 2. It processes the calculation and then releases. And finally, thread 2 gets the mutex lock, process the calculation, and then releases it. So this time we get the final output of 3.72. And that will be it for the demo of the software. And I think that'll be all from us. Thank you.